Hello, this is Professor Kim Nelson with the Jewelry Design Department at the Fashion Institute of Technology, and this is another tutorial in our series of tutorials on modeling in Rhino. This video is part of the series on Review Ring Project for JD237. This is where we left off in the last video. Here we have a completed maquette, and the purpose of this video is going to be to revise this maquette. I'm going to move the drawings out from under the ring, the reference I should say. Okay, so we can see it easy. I did a straight taper on this ring in the maquette, but in fact, when you do a straight taper, in 3 dimensions, the ring will actually look like it has a bit of a belly. It won't seem like a straight taper, it'll seem spread. So when you see this nice, smooth narrowness here, you're not going to get that with a straight taper. You're going to need to actually concave the sides of the piece a little bit. So I'm going to do that now. I'm going to be using the Cage Edit transform menu, Cage Editing, Cage Edit. When you have to have pre-selected, by the way. Back out. If I don't pre-select in typical Rhino fashion, it'll ask me to select captive objects and hit enter. If you've pre-selected your geometry, it won't ask you for that. Select control box. We want a bounding box. Coordinate system will be world in this case. Typical Rhino world coordinates, which are right down here. X is left to right, Y is receding and coming towards, and Z is perpendicular to the C-plane, or vertical here. So I'm going to pick world, just hit enter to accept it. This is important. It's going to ask for the number of points I want in the 3 directions. These are basically control points. Cage editing allows you to create a deformation box surrounding your geometry that you can then manipulate and modify to change, to transform your geometry. I don't care for the 444, which is Rhino's default, because it doesn't give me a center line, and usually when I'm control point editing, I like to have a center line. So at the very least, I'll usually go 555. In this case, since I'm going to want a certain amount of control, well, let's try 5. So click on X, type in 5, enter. Y, type in 5, enter. Z, type in 5 and enter. And after you've done that, I'm going to accept the Rhino degree of curvature, which is 3rd degree curvature in all directions. So, and hit enter. And there's the box. Now, it's really useful, and I should have mentioned this, it's useful to make sure that you have a layer other than the layer your geometry is on active when you create the box, so that the box and your geometry are on 2 different layers. This box is an object like any other. Okay, and once you hit enter for the final time, you will see the control points coming up. These control points can be turned off by using the standard Rhino keyboard shortcuts F10 and F11. If you turn off the layer, it will disappear. Okay. But once you've activated this by turning on its points, you will not be able to select this item anymore. Right now you still can, because this hasn't been activated. But once you activate the points, your sub-object is now the item inside. To make sure I don't accidentally, when I'm turning points off and on, mess with that geometry inside, I usually lock it, just to be safe. It'll still transform just fine. Okay, so here are my points. I'm going to go ahead and grab the bottom half of this box. And you can use a gumball for this, or you can use non-uniform scale, either one. In this case, I'll go ahead and use gumball. Come here and grab the Y direction scale box. If you have grid snap on, it won't work. Gotta back out of that because it's confused. Reselect. Okay, Rhino got stuck in the middle of a command. Turn off the box. What happened there is I tried to do a point edit with grid snap on, which will never work, and in that case it hung the program a little bit. Turn the points back on, and take a look at my reference image. Take a look at what I'm getting here. I'm going to take just this row of points. Scale it in. And I'll take these two rows. It's important to select the whole row of points, so revolve your view until you can get a clear shot of those. Taking a look at the thickness here versus the thickness here. The taper here. Now I can only move these points, scale them in and out. I can't move them up and down or scale them any other direction, or I will lose the roundness of the finger bore. I'll distort it. I don't want to distort it, I only want to scale it in one direction, which is why I can also do the same thing using non-uniform scale, and sometimes that's safer. So in that case, transform tab, non-uniform scale, coordinate center of scale is going, the origin point is going to be 0, because that's the coordinate our object is built on. I don't want anything to change going in this direction, so I hit just enter to accept 1, and I want to change this direction. So click for first reference, drag in, click for second reference, and then for Z I just want 1, so enter to accept 1. And that will. And I actually find this gives me actually a little more fluid feedback. So you can do either way. What you just saw or may not have seen me do, is the same thing. I just did non-uniform scale, origin point 0, nothing there, a little bit here, nothing for the Z. Okay, so you'll hear me clicking away and going fast sometimes, but that's just because I'm repeating the command, and there are steps that I've already walked through with you out loud. So there. Turn off the points and throw away the box. And there is my revised maquette. Okay? Now, a couple of things. I made one mistake, and I want to point something out. It's going to be great to take care of both of these at once. I want you to pay attention to this surface here. Sometimes, when you do cage editing, the surfaces, because they're becoming bent and transformed, have to become more complicated surfaces. And sometimes this can fight what you want to achieve. If that's the case, you have to use a different method to do what you want, other than cage editing. Cage editing can be a beautiful shortcut, but you have to be aware of these kinds of changes. Okay. Now, to fix my mistake is simple. I just didn't make a copy of this before I played with it, and you always want to have a copy of what you had before, and then you can go in and transform it. So I'm just going to copy this to clipboard. Copying it to clipboard takes it outside of Rhino, so it can't be harmed by the redo or undo process. So Control C, this is now on a Windows clipboard. That's different than going to the edit menu and taking the copy off of there, or the transform, yeah. If you took copy from here, it copies the geometry inside of Rhino. We don't want that. We want it copied out, so Control C. It's now left the program. Now I can undo all I want. And I'll undo all of my cage editing. And I will paste it back in. Control V. And that brings back the modified version. And that'll allow me to take the original here. And put it in storage. Just always, it's hygiene, guys. Always make sure that you make a copy. Oh, before I do that, I wanted to, before I paste it, notice how this surface is much simpler here than the modified one. Okay? So now that I've got this, I'm going to maquette the basic form of my ring. Not maquette, I shouldn't say. I'm going to do some finished surfacing of the finished shape. We're done with the maquette. This is the purpose of a maquette class, is to verify that you've got the aesthetics right. After that, you can use this to pirate other surfaces from, but it itself plays a lesser and lesser role. I need to grab some cross sections. I'm going to actually sweep a shank here. Now, the strategy I'm going to use to make this, and this is important, there are several strategies for making a ring, but when you have a ring with a precise top, I usually think of it as a flat top. This is slightly arched, but it's the same principle. Flat top, slightly arched. Think of a signet ring sort of solution. When you have that, really the best method for sweeping and creating a finished ring body is what I call a skirt and a shank. Okay, we're going to create a surface for the skirt, which creates the top portion of the ring, and then the shank separately. And I actually did that in the maquette. This surface right here is a skirt. If we untrim it, you'll recall it was a rail, a bi-rail sweep. You had a rail on top, a rail on the bottom, and we swept this skirt form, okay? So I even obeyed that strategy in the maquette, because it's just a logical way to proceed. We're going to do the same thing. So we're going to need to get some cross sections to work from. First cross sections I'm going to pull are going to be the bottom and the top and side to side here. So fastest tool for getting a cross section is usually the section tool. Section tool is on your curve tools. Your curve from objects pop out. I keep mine docked over here because I have a large screen and I can do that. So section tool, you pre-select your geometry. So I'll start fresh. Pre-select your geometry. Cross-section command, start of section, grid snap, here to here. That'll give me those two cross sections. And activating my front C-plane, here to here. And that'll give me those cross sections. Okay? That's a start. I'm probably going to want some more cross sections, so I'll draw one here from the center, turn off grid snap. I'm going to want it, but yeah, I could have done it at a 45. I'll make it a little less than halfway, between 9 o'clock and 6 o'clock there. And I'm going to want the same thing coming up here. This one's difficult because I want to have a nice angle. I want to use as little of this skirt as I can. I want to think of a keystone on an arch. I want this surface here to form a keystone at the top of the ring. And the rest of it I want to be swept as one piece with the shank. So I need cross sections here. In this case, to get it, I'm going to do a cutting plane. Start from 0, and I'll pull out what I think is good. Now that's going to be copacetic coming off of the ring bore, because the ring bore is based on 0, 0. It's a circle starting from 0, 0. So any angle I take from 0 is going to look nice coming off of that ring bore. But you'll see it's a strange angle coming off of the shoulder. The shoulder wants something much flatter than this. Okay, to get that, I'm going to want to rotate a copy of this and take a look. I'm going to give myself another section of this object before I continue, because I'm going to want an extra curve here for a snap reference, something to get a hold of. So back to section. I'm going to grab a grid snap and pull all the way through the object. Enter when done. I only want the outside one here, so I'm going to Control key with my little finger. Can't see me doing it, but I am. Click on the outside curves to remove them from the selection, and then delete that center curve. I don't need it anymore. Okay. And now I can take this section curve and this cutting plane, and I can intersect them. That'll give me a point right there. And I'm going to rotate this now, this cutting plane, with copy option. I'm going to go into front C-plane so that my rotation works in the direction I want it to. Remember, all transforms are construction plane dependent, so if I want this to rotate like on the face of a clock around this ring bore, I need to have the front C-plane active. Picture it as a steering wheel that you're going to get both hands on. If you can't see the steering wheel that you want to rotate with, it's not going to work. I can picture this being a steering wheel I want to use, where to rotate this, for example. Rotate point, turn off grid snap, grab that point. See, even as I pull it out, you can see that metaphorical kind of steering wheel. Then I can click and rotate this and get a predictable result. Okay? If my right C-plane is active and I hit rotate, first off, it doesn't want to grab anything, because Rhino always wants to see your C-plane, and there's no C-plane behind me in this view. But if I grab this point, notice the direction the steering wheel is in. It's in this direction. So this C-plane is nice if I want to rotate it this way, but I do not. So to get the rotation I want, front C-plane has to be active. Rotate 2D copy equals yes, because I want to make a copy. And then I want to come up with something that's kind of a compromise between the angle that's perpendicular from the ring bore, which we already have here, and an angle that would be perpendicular from the shoulder edge of the ring, which would be something like that, which is not going to work. What you really want when you're creating a surface class is you don't want any steep corners. You want things to be as close to 90 degrees as you can functionally make it. I'll show you what I mean here. I think that this is probably a pretty good compromise. Enter when done. Okay. Right now, if this is going to be a cross section between this surface and the ring, okay, I'm going to have kind of a weird looking corner here and a stretched out middle. Rhino, remember, surfaces are always a four-sided surface, a four-sided infinitely flexible piece of rubber, as it were. And the more distorted the corners become versus the center of the section of that surface, the more stretched things become, the more trouble you're going to get in. I want to have my surface as relaxed as I can get it. So this is stretched out a little bit here compared to what this is, but it's friendlier with the spine, so I'm going to take that. And I'm going to get a cross section of these two. Okay, I don't want this cross section, so I will deselect this cross section by clicking on it with Control, and then delete the other. Just a side note, you may have noticed that when I did that with the section command, I had to click, click, click all the pieces. Some commands in Rhino, when they intersect with a piece of geometry, automatically join the results and others do not. Section doesn't do that by default. So when we made this section curve, you can see here, join curves equals none is Rhino's default. I'm going to make that, yeah, see, it's going to give me strange bisection plane, I guess. And then I'm just going to exit out. Rhino's default for that particular command is to not join curves, and I'd forgotten that. So that's why I had to go through and click, 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 click. Whereas intersection command, the default is to join them automatically. I'm going to hold on to this, hide it, because I'm going to perhaps want the C-plane back for later. Okay, to finish my sweep of the shank, I need to have ring bore curves. So I'm going to grab these. I want you to notice, people always pay attention. See that little fragment? That would have been very serious if I'd have missed it. I have them all. Enter when done. I'm going to join them while they're selected. Two closed curves. You want to make sure they're closed curves. Turn off my ring. Now, these are very complicated polycurves with little bitty segments in them. I don't like that. So I'm going to rebuild them right away. When I rebuild circles class of any kind, I do them so that they have they're divisible by 4. That allows Rhino to rebuild them in quadrants, and it gives you a better circle. The smallest thing you can work with is 16. I don't usually like going as low as 16. I usually go 36. So I'm going to F5 to rebuild. 36 degree 4. So I have those. Okay. It is important to note where the seam on these are. I would like the seam to be up here. Curve, edit tools, adjust close seam. The seam is right here. That's not a good place. So I'm going to drag point to change. I'm going to put my end snap on here. Click there and then hit enter. Same thing here. The reason I want to change these is because I'm going to split these rails with this cross section. So this part won't actually be used. I want to take seams out of my curves, my sweep curves wherever I can, because wherever there's a seam, there's going to be an extra surface. I repeat, wherever there's a seam in one of your rails, you're going to tend to get a seam in your surfacing, an extra surface, unless you use surface from Curve Network, in which case Rhino can only give you a single surface. But even then, you can get kind of distorted results. It's just, once again, you're going to hear me say this over and over in the semester. It's good hygiene. Going to mirror this over here. And I'm going to split. Okay, look, I made the same mistake here that I almost made there. I could go back and do a cross section. This happened because these weren't set to join. Actually, you know what? Let's do a little class experiment. Why not? Delete this. Bring back my object. I'm going to try and do that section command again. And this time I have set to join by construction plane. Let's see if I can, by section plane, let's see if this works. Enter when done. If this is joined, I should be able to click on any one piece of it. There we go. And it deselects the whole thing. And I can delete that ring bore. That made it so that there was no chance of leaving a little piece out here. However, it also means that this is going to be crazy complicated too. It's going to have a lot of points. It's going to have extra little pieces. That's what happens when you pull curves from a maquette. So the rule of thumb, class, is that whenever you pull curves off a maquette, you rebuild them before you use them for finished surfacing. I'm going to go ahead and split this out. The split command using these two sections. I'll go ahead and rebuild this. I'm going to rebuild this 35 points. 35 is, once again, 36, 35 is good for a circle. It's 36 for a circle because I want 4 quadrants. This isn't a closed curve. I'm going to use 35 so I get a control point at the bottom. Odd numbers gives me a center, and I like that. Just, once again, hygiene, habit, rebuild. From 97 down to 35. Done. I can throw that point away. I'm going to split these rails using the same cross section. Okay, so now I have the start of my ring. Okay. These curves, I may want them for something later. I'm going to group them together, and I'm going to put them on my storage curve layer just to tidy up. Now obviously these squared cross sections are not going to be useful to me. Now when I did the section command, I used grid snap at 0, 0. That's convenient because that means that these two sections, I'll go ahead and select them and join them, because when I did section command I didn't have that join option activated in the command line. So they're joined together. I'm going to join this one as well, and the one at the bottom as well. And I'm not going to mirror that over right now. In fact, I'll go ahead and delete this side, because I'm going to have to make the actual cross sections, which will be quite different from that. Since I did the section command at 0, 0, my top C-plane is perfect for doing this, and my right C-plane is going to be perfect for drawing this. If I want to make a cross section here, I'm going to have to use a custom C-plane. And if I want to adjust this section, which I really can't do, I need to use a custom C-plane. I can't change that section because that section is what I'm going to use to cut out my little center key here. If I change that, it won't cut because it came right off that surface. Alright, so I'm going to take care of this cross section first. When you're doing a cross section off of a shank, guys, coming off of a shank ring bore, you want to leave a little bit of straight line. Okay? You don't want to come right down to here with any kind of a knife edge. It'll be gone in polishing. You'll polish that knife edge accidentally, and it'll change the whole taper of your ring. You got to give yourself a little bit of a flat wall for the buffer to rest against when it's being polished. So, I'm going to go to Curve Tools. I'm going to go to Ellipse, Diameter. No reason to be too fancy here. Turn Grid Snap off. And I'm just going to go end, end, and I'll pull this out a little ways. The distance I leave here is the distance I'm going to actually want to have down here. I'll show you. I'll come to about here, and then I will move this from quadrant to mid. And because coming off of any quadrant from a circle or an ellipse is a straight line, I can use this ellipse now to trim off the back of that cross section, and I can use the front of that to trim off the rest of the ellipse. And this will come off smoothly from that straight line, like so. I joined them. Now I'm going to explode again, just so I can remove the straight line. The straight line isn't part of what I want. Join those back together again. Delete that straight line. And see how that, I thought that was joined and it wasn't? Always double check. It says it's unable to join curves. That's interesting. So, obviously they're not lining up perfectly, so fill it. That should have fixed the problem. Yes. I want to rebuild. If I rebuild this curve, it'll be cleaner and smoother. But I'm going to lose that straightness that I want, so I'm not going to rebuild the curve. It's a little bit not great as far as hygiene is concerned, but since I'm using surface from Curve Network to make this shank, it should be okay. We shall see. I'm going to go ahead to the bottommost cross section. This one is more complicated because this isn't a straight line, but I want to have this angle coming straight off of the shank as part of my cross section. So, the way I'm going to get this, I'll go ahead and make a surface, planar surface. Select that surface and extract isocurve. And I'll pull that isocurve up to about how far I want that to stay straight. I'm going to stay here. You know, it's got an angle to it, but a straight line. Not a 90-degree line, but a straight line. I'm going to go ahead and explode this. Take this curve and trim off the ends here. Take the spine down the middle of the shank, trim off one side or the other here, and I'll do an adjustable blend curve from here to here. That guarantees me smoothness coming across and down. I'm going to hold the Shift key down so I get uniform adjustment, symmetrical adjustment. I'm going to back off the main point, the one that's closest to where the blend begins. Back it up a little, pull these out a little. That'll get me a little softer, more rounded looking curve. I'm going to mirror that across. Check my cross section, see if I like it. So far so good. Join these two pieces on. Fine. Join. Don't need this, don't need that. I'm going to mirror this across. To mirror across, I'm going to need either top or front. I'll use top, C-plane. Whenever I'm changing C-planes, I'm using our keyboard shortcuts. T for top, F for front, R for right. In theory, I have enough here to sweep the shank. I've left this in case I want more control, and I'll see if I need more control. I want a copy of this surface, so I'm going to extract surface, copy equals yes, pick the layer I would like it to go on, because output layer is set to current. Grab that surface and hit enter. That made a copy of that surface in location, in situ. Turn off the main maquette model, grab these curves and trim. Okay. I'm going to delete these little pieces of surface that were left behind. Now, I can do a surface from Curve Network, and if I do it off of this seam right here, it should be nice and smooth with this surface, in theory. My guess is, however, that this does not come off as a simple smooth edge because this curve was a poly curve, and as it trimmed, it imparted its poly curve nature. Actually, I'm going to go ahead and group these and put them into storage. I don't want those cross sections confusing me because from now on, this cross section will actually be the edge of the surface. To see if this is a multiple bunch of edges here, I'm going to come over here to duplicate edge, and just as an experiment I'm going to click. If it doesn't light up the whole thing, Rhino split it out in a bunch of pieces. If it does light up in one piece, like this did, then you're fine. An escape out. I don't really want the curve. I used it as a diagnostic. Repeat the command as a diagnostic over here to make sure that both sides are predictable. They are. Escape. If I'd have had any problem with that, I'd have gone to Analyze, Edge Tools, Merge Edge, and use that to merge the split pieces of edge into one single edge. Fortunately, we don't have to do that. Surface from Curve Network. Edge rail, center rail, edge rail. I should say outer rail, mid rail, outer rail. This is an edge section, comes off the edge of a surface. Curve section, curve section, curve section, edge section. Enter. These two should give me a choice of continuity, which it does. It can be loose, position, or tangency. Two of these are giving me tangency. If tangency or curvature aren't available, then I picked curves instead of a surface. Only a surface can give you these options. So it means that it's all looking good. These two sections were indeed coming off the edge of the surface. Okay. I can actually just do a preview and look at it before I hit OK. See if I like it. Actually, I do. I don't think I'm going to need to make an additional section here. It looks like it's not doing anything unpredictable. It looks okay. I'll hit OK. I'm going to look at it though to make sure I'm right. Because what I don't want is I don't want this coming into like a weird knife edge there. It doesn't. It looks nice. I'm going to EMAP these two. EMAP. Apparently it went EMAP off. There we go. Just so I can see how it actually looks. I'm going to turn off the curves. Going to compare that to my reference. Actually, the reference looks a little thinner than this. In the interest of not confusing everybody, I'm not going to go back and taper it thinner. I could. I'm not going to. If I really want to, I can do that after I finish the surfacing. What I do want you to notice, there's one problem with this strategy. And it'll become even more apparent when I join. Do you see that line? See this kind of kinked nature going on here? Okay. That happens because these surfaces are markedly different from each other. Even though I use smooth and all that good stuff, the tangency and all that stuff, the grain of this surface is going up and down like a skirt, and the grain of this surface is flowing along the shank, just like we want it to. But that leaves a seam. Okay? I don't like the seam. I would like that not to be there. To get rid of the seam, we're going to have to cut away some of each of these surfaces and do a blend surface in between, and that should help smooth it out. That's why it's important that the angle that you pick here, you have to have enough of this surface left to blend to. In fact, it might have been better if I made that a little lower, but we should be fine. So, solid pipe. Pipes are great cutting tools. I'm going to select the edge of either one of these surfaces. They're the same position-wise. I'm going to drag a diameter of pipe that looks good. Something like that. I don't want much. I'm going to hit enter to accept the same and enter to finish the pipe. I'm going to explode the pipe. Hold Control key and click to take out the center surface. Delete the two ends. This is not going to be long enough. It never is when you use a pipe this way. So you're going to need to extend the ends of that surface. Extend surface, just accept whatever Rhino has. It's usually 1 by default. In this case, we don't need precision. Sometimes you do. Not today. And I'm going to get a intersection between first this surface and that surface, and then between this surface and that surface. I'm going to use these two curves to trim out the area in between. And now I'm going to do a blend surface. Select the first edge, press enter when done. Select the second edge, hit enter. Now notice what's happening here. You're getting this very strange kind of S-curve. That's because they're similar enough that Rhino's kind of fighting, and it's also kind of going up and down. It's hard to see exactly what you're getting, so it's important to go with a preview. So when you preview it, it actually looks much smoother. You can see we're getting a ripple here. This seam right here, not a seam, but this density of surface right here and right here, it's causing a headache. It was causing the headache before. The headache's not going to really go away just because we have put a blend in there. I'm going to go ahead and hit this lock button so that these two hand handles move together. And I'm going to use them to back that off. The more I back that off, the less it's going to push from each side. If I go too far, I'm not going to have any blend left. It'll just not be smooth from either side. But I can go down to about there or even a little less, and it'll still give me the smoothness I want. Okay, now the trouble is this weird edge. This weird edge is not useful to us. So I'm going to extend that. Extend surface. It should be on your command line. Drop pop out. Grab the end of this and just accept whatever Rhino says. Repeat the command. And then I need to trim that off. My ring bore is going to be here on my storage curve somewhere. It's right there. I could just change layers for this, but since I'd like to just keep it where it is, I'll just copy, Control-C, paste, Control-V, and Control-D on our keyboard shortcuts will let you change the layer. I'll change the layer to light blue. Turn the dark green layer off, the storage layer. Now, of these curves, I only want this one, so I'll Control-Shift-G to ungroup. Then I'll hold the Control key down, click on the ring board to take it out of the selection, delete everything that's left. I'll extrude that straight out. Both sides. And I'll use this to trim off those surfaces so they're nice and clean. I can actually hide that in case I want to use it later. Okay, so I've got these two curves. I thought I had a curve here. Yeah, we do. I'm going to take these two curves, mirror them over. Copy equals no, so it just takes the originals. That way they will stay selected for me. Trim. I can delete them now. Mirror. Oh, yeah, copy equals yes this time, please. Start 0, pull straight across. And that's really the strategy. Skirt, shank, and a blend surface to accommodate the fact that the surfaces are so different. This still may not be perfectly smooth, but it should be acceptable. Okay. Actually, that should come out with a touch of sandpaper. I don't care for it. I should have made my this slice further down the side of the shank. Okay, I can live with that. I am going to take the time in this video to correct it. That's what I always do, guys. I'm sorry. I make these videos live as I'm making the ring, so if I see something that needs to be changed, I will change it. None of these are particularly useful to me anymore. I don't really need this anymore either, but I'll hang on to it. I need to bring back my original maquette. Actually, this edge isn't bad. I want a cutting plane, front C-plane, 0 for the ring bore. I'll just plop it anywhere for now. I'm going to move that up. I think that's not a really bad compromise, actually. Let's try that. I'm moving it down about that far. This surface is no longer useful. Intersect command. Only want this one. Control deselect the one I want to keep, delete the other, and I'll delete the cutting plane. Turn off my cat. Bring back my rails. I'm going to explode this. Deselect that one. This should already be joined together. Check it. Nothing to join. It's a single curve. Perfect. Mirror it over. And use these to trim off. Because these rails should still be perfectly valid. They just need to be shortened. Give me a copy of this surface. Curves. I'm using the edge of the surface, and surface from curve network again for the shank. Outer rail, mid rail, outer rail, edge section, curve section, curve section, curve section, edge section, enter. Preview. Looks pretty good. Okay. Let's see how this looks. This is always going to happen. You're always going to have a little conflict. In this surface, it's happening particularly bad because of the grain of that surface in my ring right here. But I can't change it. If I change it, I could end up with something that no longer matches the rest of the ring. I could try. To keep something the same shape, but to change the control point layout, you're going to have to go higher in points than it has now. Okay? So, I would go up to, and once again, excuse me. Excuse me. I am sorry, folks. This is simply, it's basically an ellipse again, so I'll take it up to 160 points. You would never do that with a surface you intended to work with editing later. That's going to become a very heavy surface. And 10. I'll take that up as well. Take it to 20. Excuse me. Hit OK. That's a much more uniform surface. It does seem to still stick close enough to my parameters. Let's see if I can still trim it. I can. Let's see if the top still looks like the proper shape. It does. Okay. So that's one good solution, would be to rebuild that. Delete. Now surface from curve network. See if we get a better outer rail, mid rail, outer rail, edge section, curve section, curve section, curve section, edge rail. Sorry, edge section, enter. Preview. Yeah, see, we're having a lot less of a jam up in there. Okay. helped. We still have a little ripple, but it's not nearly as bad. Okay. Gonna put my blend surface in here. So pipe. And it's hard to know how thick to make this surface. I've often found that when I make it really wide, it's actually worse. Usually narrow is better for this kind of a problem. But we'll try a little bit on the wide side. I want to leave enough of a room up here that I can fill at that edge. I don't want this to come any further up than about here. So, about there. Yeah. Explode, control click on the main pipe, delete the caps at the end, extend surface. It's still here? Nope. Surface, extend surface, intersect. Do one at a time. Otherwise, you'll get an extra curve you don't want. And by the way, instead of doing that, if I want to, you can just use the pipe to trim. Either way works. Leave that over there in case I want it later. And blend surface. Edge, edge. And that actually looks pretty nice. Extend this wavy edge so we can trim it off proper. Now you're going to grab this curve, extrude it out. Actually, we have that extrusion on a hidden layer right here, so I'll unhide it, use it to trim, and then hide it again. See how this looks? EMAP. There, that's acceptable. Perfect. Or as good as we're going to need. I'm going to trim out the other side. Mirror this over. And join. I do want a top for this, so let's steal it from here. Extract surface, copy equals. Yes, by the way, right clicking on explode is extract surface. You can see it right there on the tooltip. Join. And I'm going to go ahead and fill in the bore here. So Control Shift H to unhide again, to bring this back, and use this to cut. It probably won't work. Oh, it did. Cool. Usually if it doesn't work, the curves will that were there that we swept the surface with. Remember, Rhino prefers to cut with curves above surfaces. Join. Now, if we're lucky, when I hit this, we'll get that little flash of success telling me that it's a solid. There we go. It's a closed poly surface. Needs to be. Last thing I'm going to want to do with this in this video is I want to check the fillet. This demands a fillet at the edge here. Now that may just be wear and tear on the ring, but I don't think so. I think it's designed in. So I'm going to put a fillet on the edge of this. Let's try 0.4. Remember, with fillet you always type in the radius before you click, because if you don't, when you click, it'll go with whatever's in the command line. This surface here. And it'll show me what I think it's going to be. That's 0.4. I expect it will fail. It worked. Rhino's fillets are very temperamental. I don't want that soft of an effect. So I'm going to repeat the command. And I'm going to choose, instead of rolling ball, which is the more organic, I'm going to pick distance from edge, which will give us a more mechanical fillet. Yes. I think that that is too much of a fillet. I'll try 0.3. Point 0.3 looks about right to me. So I'm going to undo. I don't want to fillet this, but I wanted to know how much it would need in the future. Under Notes, I'm going to come into Notes here, and I'm going to put fillet master shank 0.3 millimeters. These notes are saved with your file. And that is the finished shank. And that's it. Thanks so much for watching.